We are live. Hell yes, we're live. Okay. It is Advent of
Nice.
Code. Technically, we're doing day 10. I actually think this is day 11, but we missed yesterday. Also, we
hmm
didn't finish day 9 on Tuesday. Uh,
I spent 3 hours working on day 9 yesterday,
we'll get
and
back
I,
to
and
Like
it.
I'm
which part of it?
close.
Like part.
Second
Part
part.
two, part two.
Yeah, part 2. Oh, let me introduce the gentleman to my left on the stream. Am I pointing the right direction? Yes, to my
hmm
left. That is Mr. James Lee, coming live from Taipei. Uh,
Oh shit!
You betcha.
yes, yeah, yeah. So like the network gods have been a little bit fickle over the last couple weeks, but hopefully this will work out. Jim has worked in the tech industry for a while. Also a big video game fan, and interestingly, he is on a path now to learn how to write programs and make digital products himself because he's very interested in the AI space currently. And so tonight's exercise will be for Dom and I to be good hosts. And,
hmm
this will be kind of Jim's, I think, first experience working on a puzzle like this. That's not true. Jim, you took CS 61A at Berkeley, right?
Oh yeah, that was the worst I ever did in a class, but probably the most I ever learned out of anything.
Respect.
The irony though is that as I'm learning now, it's just like you kind of learn the basics of just doing looping, and just like my instinct is do it recursively,
That is really
and I'm
funny.
just like, oh,
Yeah.
you have all these loops, you can just directly tell it to do stuff. Amazing.
Yeah. So CS61A was infamously like the original Weeder course for the computer science program at Berkeley back in the day, and I think up until like 2006. And this is like around the time that Jim and I were going to Berkeley. Um, they did the class in Scheme, and
Oh
so Scheme is a dialect of Lisp. Everything is parentheses. There are no There are loops in Scheme, but they don't teach it to you. Every kind of like iteration that you do in Scheme is all recursion, right? And I think it was effective at killing a lot of the joy in making computer programs. But those of us that survived the program, I'm not actually sure what to say about us. I think we're all bitter as a result. Oh,
so
Dom, is
stress
Solus Rest a melon, a fellow melon person?
sure is.
Amazing, nice. Um, okay, so we're gonna do day 10 today. Okay, so we'll come back. I think the second problem in day 9 really thwarted us. I think just as a kind of like rinsing our mouths of the taste, we'll just get into day 10. Hopefully, it'll be good.
Yeah,
Um,
let's either come back to it tomorrow or on our extra Saturday stream,
okay.
because especially if we both come up with different implementations, I'm very curious. But I'm doing like a flood fill span based
That
approach,
might be
which
an interesting.
is
One way we could do it is maybe I'll try to work on it and you try to work on it. We can compare solutions. I don't know.
yeah.
Okay,
If I can solve it, I'm very annoyed so far.
I have faith. I actually had thought about a solution where it's like, what if I just made a 1.25 gigabyte bit vector of every single possible pixel, right? Because it's like a 10,000 by 10,000 grid. You multiply that both
Yeah,
together, that is 10 billion. What if you just fill it? And then I was like, well, I don't know how to fill it, right? All you have is the edge. You still have to fill it, and it's just like
flood fill.
solving the original problem, right?
No, flood fill is just like run a flood fill algorithm, and then you can check against that grid. Yeah.
Okay.
Um, you can also make it a smaller grid using coordinate compression, which I think would apply very well to this. I've been reading about a lot of algorithms for this problem.
Amazing. Okay, so I will take us over to problem 10 then.
Mhm.
And as I mentioned, 11 is already available, and then actually is tonight. I guess Friday is technically the last day that they're going to have puzzles, right? So
Yeah,
let's res
the
no
last one's coming.
with no context of the problem you're discussing. This is interesting to listen to. Oh yeah. Yes. Well, we did stream day 9. You can see that on YouTube. That was the one where we also had 4 people, which was an amazing good time. And I would say on balance, a positive to have more people, right? Like we would.
I think so.
Yeah.
I think for it was a little chaotic trying to all figure out an algorithm at the same time, but like I bet with a little practice we'd have gotten a good rhythm there. It was
Yes.
fun.
Jim showed me something when we were prepping for the stream called draw.chat, which is just like,
Oh, that's nice.
and if we need to, we'll maybe be a little bit more expository tonight when we solve the problem. Maybe we can use that to kind of like draw on things. Yeah, 9 programmers can make a baby in 1 month. Exactly. Yeah. Yeah. 10 people can run faster than 1 person.
We literally just had this conversation at work where it was like, can we get some more staff to make this project faster? And all of us were like, no, can't do it. It doesn't work.
I mean, it depends. It depends on how much time you're talking about, right? If you're talking about a year,
Yeah.
then yes, that'll give you enough time to figure out the coordination, right? Okay, what are we doing here? We're not talking about software engineering. We're talking about like fooling around with elves here.
We're talking about software.
Yeah. Okay. Day 10 factory. Just across the hall, you find a large factory. Jim, can you see what I'm reading right now, or are you just like staring at nothing right now?
I just went to the actual website and I'm reading.
Okay. That'll be
The
great.
day 10.
You'll be able to follow along up until we do this part 2, because they hide part 2 unless you have a solution for part 1. But what I'll do is I'll copy and paste it into a text file in VS Code. And everyone's in VS Code right now, right? So
Correct.
okay. All right. Just across the hall, you find a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline and none of the elves can figure out the initialization procedure. The elves do have the manual for the machines, but the section detailing the initialization procedure was eaten by a Shiba Inu. All that remains of the manual are some indicator light diagrams, button wiring schematics, and joltage requirements for each machine.
Jolting again, huh?
This input looks horrific already. So, for example, okay, so we got square bracket in case stuff with what looks to be some kind of series of dots and hash marks, which might be a grid thing. And then we have a sequence of parentheses enclosed lists of numbers, speaking of scheme and Lisp. And then finally, we have a comma-separated list of more numbers delimited by curly braces and multiple lines of that. So the manual describes 1 machine per line. Each line contains a single indicator light diagram in square brackets, 1 or more button wiring schematics in parentheses, and joltage requirements in curly braces. So we're basically building a modular synthesizer. Is that what this is? To start a machine, its indicator lights must match those shown in the diagram, where dot means off and hash means on. The machine has the number of indicator lights shown, but its indicator lights are all initially off. So an indicator light diagram like dot hash hash dot means that the machine has 4 indicator lights which are initially off, and that the goal is to simultaneously configure the first light to be off, the second light to be on, the third light to be on, and the fourth light to be off. You can toggle the state of indicator lights by pushing any of the listed buttons. Each button lists which indicator lights it toggles, where 0 means the first light, 1 means the second light, and so on. When you push a button, each listed indicator light either turns on if it was off, or turns off if it was on. It's a toggle. Okay. You have to push each button an integer number of times. There's no such thing as 0.5 presses, nor can you push a button negative number of times. So a button wiring schematic like 034 means that each time you push that button, the first, fourth, and fifth indicator lights would all toggle between on and off. If the indicator lights were hash dot 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 dot, that's 5 dots, pushing the button would change them to be dot 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 hash hash dot instead. Because none of the machines are running and the joltage requirements are irrelevant and can be safely ignored, you can push each button as many times as you like. However, to save on time, you will need to determine the fewest total presses required to correctly configure all indicator lights for all machines in your list. There are a few ways to correctly configure the first machine. You could press the first button 3 times the first three buttons each once, a total of 3 button presses. So if you hit 3, does that turn on the third light? Is that right?
It just toggles it.
It toggles it. Okay, and then if you hit the second button, it toggles the first and third. Right.
Are these 0 index? That'd be
They are
second and
0
fourth,
index.
right?
I'm sorry. So it actually
Yeah.
So 3 means the fourth one, and so 1 3 means the second and the fourth. Is that right?
Yeah.
Yeah.
Yeah. Yeah.
Um,
So says that. Yeah.
okay. So hitting 3 turns the last one on, right? And then hitting the second one and the fourth one again turns the second one on and the fourth one off because it was on from the first button press. Then if you hit this button, it'll turn the third one on. And then that's it.
And,
right?
and you've done it.
That's
yeah.
it. Okay. Okay. You can press all the buttons except 1, 3 once each, a total of 5 button presses. However, the fewest button presses required is 2. One way to do this is by pressing the last 2 buttons, 0, 2, and 0, 1, once each. Okay, yes. The second machine can be configured with as few as 3 button presses. Okay. The third machine can be has a total of 6 indicator lights that need to be configured correctly. The fewest presses required to correctly configure it is 2. One way to do this is by pressing buttons 0, 3, 4 and 0, 1, 2, 4, 5 once each. So the fewest button presses required to correctly configure the indicator lights on all machines is 2 plus 3 plus 2 equals 7. Okay. Analyze each machine's indicator light diagram and button wiring schematics. What is the fewest button presses required to correctly configure the indicator lights of all the machines? So, I think it's actually appropriate that we were talking about CS61A and recursion and all of that kind of thing, because this is the classic enumerate all possible combinations of things type problem. Is that your instinct, Tom?
It is. That's my instinct. And the nice thing is there's a depth limit on this. Like if we find a solution of 4, we can cut off recursion for all the branches at depth 4 and say like, no, that's too long.
Yeah. Jim, do you remember in CS61A doing, or any programming context, doing the problems where you had to make change? Where it's like, you have $1, like how many different ways can you make change with these coins using like
this is that problem.
Yeah, for $2.35 or something like that, right?
Vaguely, or you just basically have to figure out how to write out all the different subsequences, right?
Exactly. So what you do is like, let's say it's $1, right? And you have all the normal US currency coins. Then let's say like, well, the number of possibilities I could make is if I used 1 quarter and then added that to the number of different combinations for 75 cents, right? Or it could be if I used a single dime plus all of the combinations that it took to make 90 cents. And so on and so forth until it went down, right? And so I think we're proposing that this problem is a little bit similar to that, right? So I'm going to go ahead and grab our input. I trust that Dom has already copied the example into the buffer. We'll see.
You know what? I didn't.
Oh, man.
I didn't. I'm off my game.
Off the game.
I'm going to do it now. God, Dom. I was just reeling at this problem.
Yeah, we can wait a little while because like advent code is very slow for me tonight. And this is a horrific input. Good Lord.
Yep.
Okay.
Ooh.
Yeah, Jim, the actual input's so bad every time.
Yeah.
But you've been watching us. You know.
Okay. So I guess we can start by doing the parsing, which is actually in and of itself pretty annoying, is it not?
It is, and let's parse out joltage too, even though we're not going to need it.
Okay. Yes, that makes sense. So what is the data structure we're going to be parsing into, just so we know? Is it going to be something like type? What are we going to call each one? Is it a...
This is a machine?
This is a machine, yes. Okay.
Yeah, type machine.
And the machine has like a target lighting, right? And that's going to be just an array of Booleans, do you think? Is that right? Like which ones are on and which ones are off?
Yep, I like that. And should we have a mirrored like current lights as well?
What does that mean?
Oh, like the current state of the machine.
Let's call one a machine specification, and then let's have a different state for the active state. Does that make sense?
Yes.
Okay.
I don't think you'll need it, but have it.
Okay. So and then what is it? The buttons? So what is a button spec? Is it a list of indexes?
A list of indexes? Yeah.
Yes. Is it worth calling the button spec its own type, or should we just call it like this? Number.
Oh, let's make it its own type. I like, type button wiring equals.
Yeah, okay.
I don't want to think about it as a two-dimensional array.
Okay. Fair enough. And then the joltage is just going to be an array of numbers. Is that right?
Yeah.
For being nice about it, let's just go ahead and parse machine spec. It's going to take a line, or it's going to take a string, right? And then it's going to return machine spec, right? And so if we wanted to do that, I guess one thing we could do is, I guess we could just split along a couple points, right? So we could do like const, what is, should we just do regex? Is that better? No, it's not. Because we have a bunch of stuff.
No, and like they gave this is such a nice input in terms of ability to split. Like just split on right bracket and left curly
Right brackets, yeah.
Okay. Do we split on right bracket? What do we call it? Target spec rest is the string dot
What is
split.
rest?
Rest is just the name of the rest of the stuff. It's a variable name.
Oh, okay.
Yeah. This particular notation means that we know we're gonna get an array back on the right side, and basically, and we know that it's only gonna be two things because we know that ahead of time, and we're gonna take the two elements of that array and assign it to a variable called target spec, and the second element to a variable called rest. So we're doing this. Is that right, Dom?
I think so, yeah, because we can construct what we need out of, yeah. We
And
don't
then
actually need the rest of
target spec is going to have a leading bracket that we want to get rid of, right?
Correct, yeah.
So is it target spec equals target spec dot substring 1 in the rest of that? That's how we get rid of the first character. And then the targets are then sorry, my cursor keeps jumping around. I think live share is having a bit of an issue.
I think that was me, yeah. Sorry.
No worries. Is target spec dot split on comma? Is there spaces in there? There's not. Okay. Whew.
Not even commas, yeah. Split on empty character.
And then I think we can do map number. I think that'll work. I saw that that's a thing that people do.
Wait, sorry, for target
it's a Boolean
array.
Okay,
and,
yes.
So you're one ahead. Yeah.
Something like that. If it's a hash mark, is that right?
Yeah, that seems good.
Oh, and yes, we're splitting on nothing. Yes, sorry about that. Okay, now we do the button with the wiring spec. And then we have the rest. And this one we are splitting on this, maybe? Space open curly bracket.
Yeah.
Yeah, okay. And then does the, and why don't we split this one on closed bracket space, just so we don't have to worry about that first space on rest? Does that make sense?
So this is, it's rest dot split for
Yes.
the second one?
I don't think it's letting me rebind rest here. I don't like this.
No, that's okay. I mean, we can call this joltage. That's what it is.
Spec, right? Or it's the string. I don't know. I'm maybe using the wrong variable name here. If the machine spec is
close
parsed, let's do it like string, right? So if the wiring is, we are going to target or wiring string const buttons equals the wiring string, and we're splitting that along just spaces, right? And then we're going to get a string back. And then do we have multiple characters for any of these? All the buttons are single character, right? I guess we're...
Yeah, it looks like.
And then, so the thing that we're getting, S is going to be a string that has parentheses and numbers with commas separating them, right? At this point?
Yes, correct.
Okay. And so this, we're going to take the substring. We want to get rid of the parentheses, right?
Mm-hmm.
And then would it be s.length minus 1?
Minus 1. Mm-hmm.
And then we're going to split that by commas.
Split on comma.
And then we're going to map that into numbers, right?
Huh.
Okay.
Whew.
Let me call this button string, just so it's a little bit more legible at this point. Jim, just so you know, line 21 map number means we're going to convert the string 0 into the number 0, so we can do math on it. I actually don't think it does matter, right? Because we are going to use it as an array index at some point. Okay. Okay, finally the joltage. And this one, we know that joltage string is like curly brace, bunch of comma separated numbers, and curly brace, right? So const joltage equals the joltage string. It's very similar to what we had before, right? Joltage string length minus 1.
Yeah, we're gonna start at 0 because we already took the front brace off.
Oh yes, good call. And then we are going to map that. Oh no, we need to split it now. The resulting thing just a comma separated list of numbers, and we're going to map that by number, right? And then we return target buttons joltage, right? Okay, so I guess we'll go ahead and just say like the button spec or machine specs.
Machine specs
Is equal to lines dot map of parse machine spec. Is that right?
Mm-hmm.
All right, let's run this. And let's do let's JSON stringify that. It's
yeah.
It's ignoring or it's eliding some of the output here. Okay, I guess we can verify the first one. False, true, true, false. It's 3, 1, 3, 2, 2, 3, 0, 2, 0, 1, and then 3, 5, 4, 7. Okay, so that looks pretty good. Let's make sure we got the last one in there too, right? False, true, 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 false, true. Is that right? Then 0, 1, 2, 3, 4, 0 through 4, 0, 2, 4, 5, 1, 2, and then 10, 11, 11, 5, 10, 5. Okay, that looks pretty good. That was by far the most complicated parsing job we've had to do this year so far, which I think I'm grateful for. It wasn't too bad, right?
Yeah.
Okay.
So far.
Yeah. Okay. So we're probably going to have like function solve of something, right? And then we'll have a spec. And then we're going to have current state, right? This is the thing that you wanted to add to the spec originally, Dom, but I think I'm right now modeling it as like a separate variable that we can iterate over.
I like the way this is going. Yeah, okay. That makes sense.
We'll call it just like state, and that's just an array of Booleans, right? And then what else is there? Do we need to like pass in how we got there, or the recursion we'll cover that?
I was gonna say if this is recursive, we would want a depth. If this is our function for recursing, I'm not sure it is yet.
I think it will be.
Okay.
When you say we want a depth, is that because we have a cutoff?
It probably helps us if we do breadth first. We could choose to cut stuff off.
The problem is the cutoff needs to communicate across the recursion tree, right?
Yeah, that's pretty hard.
It's not, well...
Maybe it's kludgy. We'll just...
Let's try it. Let's
just go through all of them?
Let's try it. Yeah, let's try it. Go for it. Jim has a good intuition. So what is it returning? Is it just returning the... Is it returning the buttons that we pressed? Or is it returning just a number? Is it number or number array? It's basically either it's the number of buttons we pressed to get to the
I
target.
think it's number of button. It's number of button presses is the output, I think. Right? I remember saying it's like, in the end, I was like 2 plus.
Yeah, so we don't care about the actual buttons that we press. We're just returning stuff. Where we might care is caching, right? So we might care that we have, I guess we'll cache based on state, right? Well, like if we've gotten to a certain state multiple ways, like if there's multiple ways of arriving at like an intermediate state, we only need to solve for that once, and then if there are other paths that get to that point, we can store it in a table and not recalculate, right? Does that concept roughly make sense, Jim? I know that's a little bit tricky.
I don't know. I don't see why you would need to. Like, I'm thinking you basically figure out if any subsequence can solve the problem and how many button pushes that is. And then let's say eventually you solve it and that's like 6 presses. You just keep going until you beat 6.
Right, but I guess the thing is that like let's say I press like button 1 and then button 2 and it gets me to some state, right? But then I could also get to that same state by pressing button 2 first and then button 1. Those are 2 separate like paths down the sort of recursion, and you don't want to recalculate the second time because you already did the work the first time.
Oh. Yeah, I wouldn't do it. I was thinking you basically, for any combination, know how many times the nth button was pushed. And then if that number is even or odd, you know the switch was on or off. And they do it that way. So you're not saving a state of the lights. You just basically say, okay, I've got 3 sets of it. I've got like 1, 2, and then 0, and then 4, 5, 6. And then there, and let's say there's only 5 buttons, you basically count how many times for any set, you count how many times the nth button was pushed. And then if it was basically pushed either 0 or an even number of times, you know that if it was actually toggled on or off, and then you just evaluate that. Right. Does that make sense? It's like for any nth button, you count how many times it was pushed given a set of instructions. So you might then end up like, okay, I have 5 buttons and it's like 0, that was pushed once, twice, 0 times, 1 time.
Yeah.
And then that evaluates to on or off, and then you just compare that against your spec.
Yes. So I think what Jim is saying, which I agree with, is that the order in which you press the buttons doesn't matter.
Doesn't matter.
Yep.
Yeah. Yep. It just matters how many times it was pushed.
So, but I will say though that like for a caching strategy, I think that the way we would express it right now is better.
And
maybe
what do you need to cache in the first place?
Maybe I can write this out and we can see if it'll work, or maybe it might not. Right? How's that feel?
Yeah, let's code or pseudocode it. Yeah.
Okay. So I guess what we're saying is, so how do we know if we're not like infinite? So here's the problem with this is that like when we get to this state, we're gonna like basically try pressing each possible button, right? There's gonna be a recursive call for every single one of these things. And so we need to know whether or not we're gonna we need to avoid infinite looping, right? Because like one thing you could do is you could continue to press the same button over and over and over again, right? And maybe this is a little bit related to what Jim was saying. And like, if that's like literally, if we write the naive recursion, which is basically like for const button of spec dot buttons, we would do we would apply the button. Well, let's see how we have function apply, which gives you a state and then a button, which is a button spec. Is it button wiring? And then it returns a new state. right? This is basically the effect of pressing those buttons, right? Let's just assume that does something, right? If we do the naive thing and we just say like const next equals apply of state and button, and then we do like solve of next, right? That's your recursive call. This is just going to go forever, right? Because you're going to continue to press the first button over and over and over again, right?
Yeah, exactly.
So that means we need to like, I think we need to have some kind of cancellation that recognizes which things we've already arrived at and then to cancel out of that, right? So it's not so much caching as it is like a cancellation list of things, an ignore list, right? So something like, or it can be a string. We can stringify it, right? We could just stringify the state if that's easier. What do you think, Dom? So what I'm saying is like if basically the ignore list contains, like includes next, I mean, we'd have to stringify or something like that, then we skip.
Yeah.
Does that make sense?
Oh, I see. Like a state to ignore. Yeah, that makes sense.
Otherwise, we're just gonna like, otherwise this recursion, we're always gonna hit the same, we're always gonna like call this recursive call, get the first button out, press it again, and then we're just gonna like continue to see the same thing over and over and over again.
Right. And I guess that's, yeah, ignore is sort of a way to cache or memoize what's coming in.
Yeah, so
Like know that we've already been there and gotten there faster. Would it make sense to have this be a cache outside of the recursion? Because like if we get to that another way,
we would have.
do we want to stop recursing that in this path too?
We want it. Yeah, exactly. We want it to be able to update it by reference. Is I think what you're saying as well. Which I think will work if we do it this way. But I think you're right to say that maybe we just keep it outside. Ignore list, which is I think strings are better because you can check it really quickly.
Yeah, especially for equality like that. Array equality scares me for this sort of thing. We'll have a weird, unexpected.
So we'll call this like ignore key. And how do you want to actually serialize it? Do you want to just serialize it back to dots and hashes?
Might as well, yeah.
Yeah.
So Rez says, do you want to also store the number as the value for the key, number of presses to get there? Yeah, that's what I was thinking. Like, can we store the, like, you know, did we get there in 5 presses? And if we're currently at depth 2, actually, we've got a better solution. We should replace it there.
Right. If you know the depth of how far you're at, right? Like,
yeah.
Oh, because you should actually continue recursing if you can beat the. If
you're right, if you've gotten to this state with a better depth, you should keep going.
Okay, so what we're actually saying is this is a map, right?
Yeah.
Of the ignore key.
Quick question.
Yep.
Is the when you say depth, you mean basically
like number of button presses we've used to get there.
So let me add it in here to make it explicit, right? Like,
does it matter that you have to that the sets of wiring instructions aren't like you'll have a set of wiring instructions. Each of them could have a different amount of button presses in there.
Oh no!
And you have to apply the entire.
You like each. This is one button press here, right? When you press this button, it just like toggles 5 things at once. Does that make sense? And that just counts as one button press. I don't even know if I'm answering your question. Sorry if I'm not.
Is that a button press or like a? All right, why don't you keep going? I'm just thinking. Yeah. I'm just thinking more that we have button presses, but then we also have sets of instructions, of which each set of instructions can have a variable amount of button presses. So you're talking about depth. You're talking about depth of combinations, or just
correct me if I'm wrong, but we have lights, and then each one of these things are buttons. And if you press one of these buttons, they will toggle the lights
Correct.
in that list.
Yeah, so like the 5 numbers in parentheses is still a single button that's toggling five lights with a side effect that it triggers.
But if it's like 5 button presses in that in wiring instruction, that is 5 button presses.
No, it's like one button with like 5 wires coming out of it that turn on or off lights, I think.
Yeah. So I think, Jim, where the confusion might be is that this is not a list of separate buttons, nor is this, nor are these buttons. These are lights, and this is like what this one button is wired to. It's the lights that this one button will activate or toggle, right?
Oh, got it. Okay, that actually makes it, I think, easier.
Also, there are 4 lights.
Anyways, keep going. There are 4 lights.
Okay. So I'm just calling this memory. And then let me call this like light state. That's really what it is, right? It's like lights. And then the sort of like the state key is like, lights are Booleans, but what do you want me to actually, how do you want me to serialize it? I can just serialize it as strings. I think this will just work. It'll just be like a weird string of like, it'll be like true, false, 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 true, like kind of smashed together. Is that right?
Oh God. I mean, you know what? It'll be equivalent. So yeah, whatever.
It'll just be hard to read if we ever try to like.
Yeah.
Yeah. Oh, the comma separates it.
We can fix
Holy
that later.
Shit.
Yeah. Well, that's nice.
That is surprising.
That's
right? Because if it was like A and B dot join, you wouldn't expect the comma to be there.
No, because you're joining. I think your string.
Oh, I see. It's because I'm not doing this.
Yeah.
Okay.
There you go. Yeah. I don't hate the comma.
I don't hate the comma either. Yeah.
It's always gonna be there. Yeah.
Okay. So do we put an early out here if we say like const previous equals? We're gonna look it up in the memory. Did we get here before? Right.
Mm-hmm. Mm-hmm.
If previous is not null and previous is less than presses so far, then we're done, right? That means we've like recursed a number of times to get to this particular state of the lights, but we've already beaten it on some other part of the recursive tree, right?
Yep.
And so what do we return there? Or is the memory what is the memory actually saying? Is it the number of presses we got to a particular state, or is it the answer? Right.
Right, because should we return or should we reassign presses so far? Because we don't actually care.
We don't want to continue though, because there's another thing in the recursive
right. This is
stack.
infinite. I think we just say I think we just return.
We quit. Right. Jim, what this is saying is that this function can either return a number or it can return some undefined value or null, basically. And what we're saying is that this function can have 2 categories of results. Either it returns you the number of times that it either returns like the answer based on the input, or it says I'm not going to try to solve this because I don't think you should continue. And that's what this undefined is, right? Okay. How are we doing so far?
So far, so good, I think.
Okay, so that means that this ignore statement doesn't need to happen anymore, right? We'll just call solve next. And then here we'll say, is this where we write the cache right into the memory, right? And if the result is undefined, we continue, right? Otherwise, we write it into the memory, right? So we need to look up the previous thing again, right? And then is it complaining about, is it possibly undefined? Oh, yes. So Tom, this is like a TypeScript TypeScript kind of like like Arcana, but I have gotten used to doing this. Basically, to see if something's undefined. Actually, I think we can just do triple equals undefined. Let's be very, very strict about this. Either you're not treating undefined as the same thing as null, or if you're in like a code base that is a little bit ambiguous about it, I think I use equals equals null for everything to kind of like serve as the.
So wait, does undefined equals null in? Seriously?
Yes.
Oh man, I'm learning new JavaScript facts. I don't like that. I don't want to learn new JavaScript facts.
There is, in fact, there's like a lint rule. Jim, I was telling you about the idea of static analysis, and you can literally write JavaScript programs that analyze other JavaScript programs to give you like, and it's like a thing you do in professional programming a lot to just like make sure that you're like basically writing with a particular code style and you're not using bad patterns and that kind of thing. And one of the things that they do is try to tame down some of the excesses of the original language, because the original language was like written in a very undisciplined, or designed in an undisciplined way. And one of the rules, Dom, is that like you want like strict undefined or null compare, or you want strict type comparisons. But one carve out you can do that is like built into that lint rule is like null and undefined, because it's like so common to do that. Anyways, that was a waste of time to talk about. Is this recursion done?
Let's find out.
I guess we now need to like return a value, right? Is that right?
We need to finish writing the apply function as well.
Yeah. So let's finish up here and then we'll go back to apply. How's that?
Yeah. Oh yeah.
So do we need like a let best equals infinity or undefined? Maybe. And then we'll say if the result, the result is defined here, right? So we're just going to say best, if best is undefined, then best is equal to the result. Otherwise, best is equal to the minimum of what it previously was and whatever we just got. Does that make sense?
Mm-hmm.
Do you want to ternary this, Dom, or do you like it the way this is?
No, I don't mind.
Okay. And now we return at the very end of this result, right? Did I put this in the right place? Doesn't like it.
Result is defined inside this for loop.
Oh, best is what I want to return. I'm sorry. Okay, before we go to apply, can we just like gut check this algorithm and just see? I'll narrate. So we are somewhere in the recursion, right? Machine spec never changes, right? The lights are just some set of trues and falses representing the current state. It's not always going to be blank. It's going to be it's however far along we were. And then this is the number of presses it took us to get there, right? So the first thing we want to do is make sure that we don't continue if we don't have to. So, what just happened there?
Oh, sorry. I was trying to follow you.
Okay. We're going to look up the current state that we're in. And if there was in the memory, we got there somehow, right? And we got there in fewer button presses, there's literally no reason for us to continue right now, because like there's no way we're going to beat the other like recursive call to the right answer, right? Because it's necessarily going to come up with a result that's at least one better, right? So there's no point in us continuing. So we're just going to say, hey, this particular thought experiment is pointless. Let's get out of here, right? Otherwise, what we're going to do is we're going to basically apply each button press that we know about to the current state, and then pass it into the recursion again, right? Do we want to do something like let best global best? It's literally a global variable. And we make this infinity or undefined or something like that. And if we get a number, the global best equals math.minimum of whatever it previously was and the current best. And the reason why I'm doing this is that if presses so far is greater than or equal to the global best, then we should just stop.
Return undefined. Yep.
Yeah.
Yep. That makes sense. Yeah, we're going down like a unique state tree of unnecessary work.
Right. Okay. So to reiterate,
you start infinity just to make that min work for the first time. And
Exactly.
Find something.
Exactly.
Okay.
Yeah. Now, theoretically, in this like interior best, I could do something similar to that, but I want to return that, and I want to basically specify like what happens if we get to this line 62, like every single button that we try to press. Then actually down here we just say we weren't able to find an answer, right? So we return undefined. Okay, so this is the recursive step here. What we do is we take the state that we were given, and we basically try it with each button press, which with this apply function, and then we get the result.
We're not checking.
Yeah.
We're not checking that we've reached a final state anywhere in here.
We are not. So we could do that after this. So if...
Or... Yeah.
We could do it in here as well, but like the thing is like all of these checks that we're doing, it's a little bit ambiguous whether they should go here or before the recursion or after the recursion.
No, I like this. I think your intuition was correct. That's a good spot for it.
Okay, so what are we saying here? So like if the state key equals what we want to get at. So how do we get to the result? I actually learned a new thing.
Okay. I was in the spec.
Oh, it's not search recall. It is in the spec, but how do we compare these two?
Spec.target.join equals lights.target.join
equals state key.
Wait, what is state key? Oh yeah, state key. Yeah.
Okay. Should the spec just have the original joined version of it, so we don't have to? It's not gonna. That's actually not gonna matter. If we have to join every time, it's gonna be fine. I think, right?
Yeah, I'm not worried about wasting resources joining on the doing the Boolean join.
Equals state key. That means we've got the answer, right? So it's just presses so far.
Yep.
Because we're never going to improve upon this. If we press more buttons, we're just going to make the answer worse, right?
Correct. Yeah.
Does this need to set a cache? Or
so we're gonna because we get this back in result, and if it is a number, we go and we write it to the memory at the end of this before we return best. So it sets the cache. So we apply, we solve. Solve says, "Hey, I'm good."
Dom, do you think it's better for us to set the memory here, or set the best here? Because this is actually where we're getting an answer, right?
Yeah, I think it's kind of fine either way.
It's debatable, yeah. The fact that we're setting like the local best here makes me want to set the global best here as well.
Yeah, I think that's reasonable.
And the reason why we need the local best is, well, we only need the global best, don't we? Like, we shouldn't be trying anything that's worse than the global best, right? Do we need the local best if we have a global best?
No.
Okay. So if we clean this up a little bit, This will just be a result, right? And that means we can set this inside of solve, right?
Mm-hmm.
Sorry, not inside of solve, inside of this, like, this thing here, right?
Yeah.
And I don't think we need a return value anymore. This actually cleans it up a lot, right? Because we just need to read global best after calling it on the original thing, and that's the answer, right?
Oh, wait a minute. That doesn't, because we're gonna set that in like. I guess we're setting it here. We're gonna go down. No, you're right. We can just set it. Okay, yeah.
Well, we are setting this memory, so I guess maybe what's confusing is like, what's the memory? The memory is to basically like make sure we don't infinitely loop, right?
Yep. And you're saying return global. You're saying it doesn't matter. We don't even need to return global best. What do we return? 1? True.
We return nothing.
Well, undefined sort of a signal. So should we return?
Oh, it's a signal that we don't set the memory. But no, because we do care about, we're setting the result in the memory right now. So if we're not returning a value from this function, we need to figure out what the memory should actually be.
Yeah.
Is the memory actually presses so far? Do we say we got here in this number of presses? So if you're trying to do this with more presses than, or if you're trying to do this with less than, unless you're doing with this less number of presses than what's in the memory, you shouldn't even do this at all.
Yeah, and is that presses so far, or is that presses so far plus 1? Because that's like our recursion value. Or should we assign this sort of like const new presses?
So what I'm proposing is that we do the early out up here.
Mm-hmm.
So what we would do is we'd say const best for this state, right? That's basically what we're saying, right? Memory.get of state key.
Mm-hmm.
And then if it's defined, and now this is the question: is it greater? Is the best for the state like less than or equal to presses so far? Then we just return. We're just done.
Mm-hmm.
And then do we write to the memory right here? Do we just do it right away?
Okay. Yeah.
All right, let's clean this up a little bit just so we don't have return values anymore, and just let's sort of see if this all makes sense, right? I think you might be right, Dom, that we might be off by 1 in terms of like the button presses that we're passing in there.
Mm-hmm.
And then we're setting all the memory, so all this stuff goes away, right?
Mm-hmm.
And we don't need to return anymore. So this is like theoretically cleaner, right?
Yeah. I want to see this. Oh, we still haven't applied. I want to see this running soon.
You just want to run it. Okay. You're getting stir crazy. Okay, I get it.
Well, I'm getting the. Are we missing anything crazy? Yeah.
Okay, so what is this saying? Do we do const next? I learned about this function the other day from Salmon. Do you know about structured clone, Dom?
Is this a?
It's a deep clone that just exists. I guess we don't need this for an array. This is dumb. Why am I doing this?
Oh, that's nice.
Yeah, we'll
This is
like
cool.
this. Yeah, because it's cool. Yeah, and then so for B of button wiring, next B equals not next B. This is the toggle, right?
Mm-hmm.
Does that seem right?
That seems.
So Jim, this notation is to basically just like make a clone of the state. So we're going to get an array, but we don't want to modify this one. So we're going to create like an array with the same contents, and then we're going to loop over all the buttons for this wiring diagram.
Right, this is indices. Yeah, I like that.
And then we toggle, and then just return this new clone, right? Okay, and then so what we're going to do now is we know that it parses. We're just going to call solve on machine specs. The initial lights, how many lights do we have?
I think it was 5. You just talk about in the instruction, the first one they had?
Yeah. How do you...
The first one is 4 lights.
4 lights.
It's in the spec though, right? It's the target. Is that what it's called? We need to solve for each spec, right? So basically, it would be like result is 0 for m of machine specs. Solve m dot. Why is it not finding it? Oh, because I didn't do a const. So how do we make, do we clone this? No, the target's what we're trying to go to. We just need, we need an array of falses that is this length, right?
Yep.
What's your favorite way of doing that, Dom?
I don't have one in JavaScript. I would use Ruby. No, isn't there a way to pre-fill an array with array fill?
I think the way you do it is like...
It's like a short one-line map or something, right?
It's like new array and then like m.target.length. And then you do lights.map false. Something like that.
Whoa.
That's horrible, isn't it?
New array, where is it?
Is it comma? Is it just comma false?
Dot fill false.
Holy shit. And that will return the array back, Phil?
Looks
yes,
like
it returns the modified array. Okay.
Yeah.
Okay. So now we return lights. And it's 0 presses so far, right? Is that correct?
0 presses so far, yeah.
And this is an any. Oh, God. To tell it's a Boolean. And then what we have to do is we actually need to set the global best to infinity every time, right?
Yes, before each solve.
Yeah, I mean, one thing we could do is wrap this whole solve in like an object called solver and create a new solver for every problem, but I think it's fine. I got you.
Oh, great. Oh, and then it's not res, it's res plus equal global best.
Yeah. And then,
I want to put in if not infinity, but I'm going to trust that that's happening.
Okay. We're just going to run it. 7. Was that the
That is correct.
That is correct. Okay. Should we just run on the input and see what happens?
Yeah, do it.
All right.
That's what I love.
That's the key quote that I want to hear from Jim every time. Send it.
Send it.
Yeah. Okay.
What else are you going to do?
Infinity.
Now we're talking.
Now we're cooking with gas. Okay, it's bad when the example works, but then the problem doesn't work. Right?
This is how my day 9B solution's going too.
Yeah. Let's try to debug it. We're at 8 p.m. Pacific. We have another hour on the stream, but let's try and solve this in the next 15-20 minutes, and we'll get to the topic, the game topic of the evening in a second. All right.
Yeah. Can we print out which ones we're solving and which ones we're not in this
we
loop?
can print out. I guess what you're saying is like which ones do we get to after all the early outs occur, right?
Yeah, well, no, I think I just like for these, I'm curious which actual machine spec we are.
Oh, this got moved. This memory set should be down here.
Oh, great.
I think, right? No, wait. Why are we getting the memory twice? It's like we repeated the same condition twice.
I think because we were refactoring.
Okay, yeah. So the best for this state is whatever we get out of the memory. And, oh, we need to clear the memory between every single thing, too.
Oh, yeah.
This is why wrapping it in an object might be better.
Yep. We have. It's just the whole program.
Here, let's do it like, fuck it, let's just do it. Solver. It's got this stuff in it. It's got a solve in it. Doesn't need the function keyword. Close it down here. And then it's going to be this stuff. Yeah. Here, I'm going to use Command D. It's going to happen.
I'm out of here. You're doing it.
No. It's fine. It's fine. Okay, wonderful. And then I think global best can just be called best now.
Yep.
And then we can get, I guess I'll just make these all public. Why am I worrying about data encapsulation here?
As plus equals solver dot best.
Yeah.
Is that it?
Yep.
All right. You want to get on the full input or the example?
I'm running it on the full input, and it's like infinitely recursing, or it's just taking a long time.
Or is it working? Yeah. Okay.
Oh
okay,
no,
469.
This is let's just see what happens. Let's just do it.
Oh, Celis Res was like, you gotta clear the memory cache. They called it. Sorry, we were focused.
Yeah. All right, that's the right answer. We're gods of recursion here. I'm gonna do one cleanup.
All right.
Because it bothers me.
Okay.
Because we're gonna move on, are we not? We're gonna move on, right?
To part 2. Not to part 2?
I think we at least gotta take a look.
Yeah. You gave us 15 minutes. Let's use our 15 minutes.
Okay. Yes. Here, I'm being a psychopath here. Okay, like I need to do this. It's the thing I need. Well, I must be so annoying to work with. I'm just like wasting time.
No, you see, this is the part where like you're doing the thing that I'm just like, I don't feel like making this code better, and then you're like, no, we gotta make the code better. It's
just polishing inside the cupboard. That's a good thing.
Yeah. And it's really slow, mind you. It is slow, but as long as it gets to 469, I'm happy. I'm actually curious how slow. Like, where to time that. 7 seconds, 7.7 seconds. That's good enough for government work.
I can live with that.
Okay, yeah.
This is also, what is this, 179 line input with like figuring out we did kind of brute force it. Let's see how bad the joltage is.
Oh, yes, let's do it. Okay, I'm going to be another psychopath, okay?
Oh, yeah, but that's nice.
Yeah, Dom respects the
I like that.
Yeah.
Though,
Oops.
Can you use a new keyword like that? Great.
How much great Arc Raiders chat have I wasted today?
Oh no, this is what I'm here for.
This is why we're here.
Yeah.
So watch me flounder.
I can go get ganked by noobs and arc raiders anytime.
Okay, yes. All right. Okay. All right, we're going on to the next problem. In fact, I will bring it into a prompt just so Jim can see it. How's that sound?
Do it. Oh yeah, let me run this on my input.
Oh yeah. See if you can beat 10. See if you can beat 7.5 seconds.
Yeah, but I got the fast input, obviously.
Maybe your computer's just better than mine. I am running a lot of stuff on my
Alright.
computer right now.
I'm running this on your computer, I'm pretty sure.
Oh, then never mind. Then I think your input is better. Are we good to go?
Oh, I mean, I'm in 10A. You've already copied it to 10B, right? Don't worry about me.
Okay.
Oh, but yeah, sorry, yeah, I'm good to go. I'm good to go. Let's look at the prompt.
All the machines are starting to come online! Exclamation point. Now it's time to worry about the joltage requirements. Each machine needs to be required exact. I know what this is going to be. You have to minimize the joltage for button presses. I already know, right?
Okay.
Each machine needs.
We've kind of done the caching thing though. I bet we can just add it.
You think so? Okay. Each machine needs to be configured to exactly specified joltage levels to function properly. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increasing the joltage levels. Ignore the indicator light diagrams. We're not going to finish this. This is actually much more complicated than I thought it was going to be. The machines each have a set of numeric counters tracking its joltage levels, 1 counter per joltage requirement. The counters are all initially set to 0. So the joltage requirements are like 3, 5, 4, 7, which means that the machine has 4 counters which are all initially 0, and that the goal is simultaneously configure the first counter to be 3, the second counter to be 5, the third to be 4, and the fourth to be 7. The button wiring schematics are still relevant. In this new joltage configuration mode, each button now indicates which counters it affects, where 0 means the first counter, 1 means the second counter, and so on. When you push a button, each listed counter is increased by 1. So basically, you need to target. So actually, this is simpler than I thought it was going to be, but not as simple as I originally thought it was going to be.
It's kind of the same problem, except
you just have another target to hit, right?
And it's a different target. Do we still care about the lights?
I think we still.
It's just joltage,
or is it just joltage?
It looks like it's like they just changed the constraint to number of presses. I don't think this is that as bad as it looks.
Oh, really? Okay, so this is the put together a certain number of coins kind of thing again. So we don't really care about the lights at all.
The lights are just not a thing anymore, right? Yeah.
Oh well, shit.
Huh.
Glad we parsed the joltage.
Glad we've heard. So really, this is just changing apply and.
So, does the joltage you can reset? Is that what is below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the. Oh, you just hit the switch. I'm sorry. This is just like.
Oh, we've cranked it into joltage mode.
Okay.
Yeah.
Yes. Ignore the light indicators. Now we're just doing joltage. Okay. I think we can do this.
It's hard to determine what the flavor text was versus the actual problem on this one.
Okay, I think we can do this.
Yeah.
So
I think this is pretty straightforward. We're just changing what we're configuring. Yeah.
So I'm going to rename this I'm going to call this the light target, and then this is going to be the joltage target.
Yep.
All
right. Our example is 33,
and these are the wirings. The example is 33, did you say?
Yeah, that's our target total for this one.
Okay. So now I think that how do we want to serialize? I think the serialization of the state is the same. Instead of calling it lights, I guess we'll just call it state.
Yep.
Or it's just joltage, right? Maybe I can just give it the name that it actually is, right? Mm-hmm. And this is still about minimum number of button presses. Is that still what they're asking us for? I should probably.
Yeah, it's fewest presses to get to the joltage.
Okay.
Yeah, Jim said.
Okay, so presses so far are still relevant, but the apply is different, right? This is actually numbers, right? And then what we're doing is for the button wiring. Just tell me what the button wiring is. What is button wiring again? Is it an array of numbers?
It's an array of numbers, yeah.
Okay, so
instead
it's
of
like
instead of
for
the
let I
toggle,
equals 0, I less than next dot length, or wiring dot
wait,
length.
I think the apply you had there was good, but instead of the toggle, it's just +1 because we don't. You can't subtract.
Oh, I see what you're saying. Sorry, I got confused. I thought the joltage. You know what? It's fine.
Right? Yeah, it's like the numbers aren't the joltage. The buttons are still just the buttons. It's silly.
But I do think that like we want to match indices, right? Or no, we do next be plus equals 1.
Yeah, exactly. That's all it is.
And then this is now numbers that we're returning, right? And then the joltage is now an array of numbers. We're filling with 0. And this is an array of numbers. And we have another early out condition, which is if any of the joltages are over their target, then you can't go down this route, right?
That's correct, yeah.
Where do we want to check that? I think we check it early, right? If the specs joltage target is less than the joltage target, the current joltage, then we're done. Right, this is not going to give us the answer. Is that aligned correctly?
Yes, I agree with that.
Okay. And then this stuff still matters, I'm assuming.
I think everything else is the same, yeah.
Do we just run it?
I'm just gonna run it. Infinity. Boo.
This is on the example, I take it.
That's on the example, yeah.
Okay.
Why infinity?
We're doing light target still down here. So this is joltage target.
Oh, and here as well. Not that that was just length. Okay, that probably mattered a lot.
Yeah. 33.
Boom. 33.
That's what we wanted.
Give us that full input. Let's do it. Please not infinity. A lot more button presses.
There's a lot more button presses, yeah.
Yeah. Now we have basically brute forced this sucker, huh?
Well, we've added a fair amount. Well, a lot of our exit conditions.
I mean, you could have gone through every combination.
Right. Yeah. Exactly. We're doing lots of early optimizations. Actually.
Yeah.
Not quite.
I think what makes this not brute force is this exit.
Yeah.
Well, and then some of these other exits are necessary for not recursing infinitely.
Oh, but we blew the stack. Damn.
Maximum stack size exceeded.
Wait, that's map maximum size exceeded?
Oh, map maximum size.
What does that mean?
It means that we've inserted too many things into the map. Does that make sense? The map should only have... Like, what's our targets here? I mean, I guess some of these, like, you have, like, 128 times 145 times 145 times 128 times 118 times 6 combinations, right? So like, the map is going to be
we could have
big.
inserted a lot. Yeah. Okay.
That is interesting, is it not?
Yeah, what can we...
Is this a horrible math thing where...
Yeah, I wonder.
Where we have to subject this to numeric analysis, right? So, for example, like, do we actually have to think about the wirings? rather than just applying it recursively.
That's what I'm wondering.
I wonder what the maximum map size actually is.
Well, and like, can we get away without a map? Can we just use an object, like a record string number, and call it a day?
We could.
What else could we do to reduce this?
It says, is there a documented limit on the number of entries in node's map? What? This sentence doesn't make sense. V8 developer here. I can confirm that 2 to the 24th is the maximum number of entries in a map. That's not a bug. It's just an implementation defined limit. 2 to the 24th is a very large freaking number. I'm actually kind of shocked that we're hitting it. We must have a bug. I feel like, what is the maximum number of combinations that you can put into this one, for example? Or even this last one. This last one's like the really big one, right? Should we console log and actually determine which one we're failing on?
Yeah, I think let's log out the machine spec just to see which one is actually blowing up.
Okay. When I'm putting the curly braces in the wrong spot. Now this is a return. And this is like a const res equals this. And
okay, so
yeah.
All right, I think I'm seeing some of our problem. Yeah, like if you just multiply all those numbers together, like 140, 165, 188. I even left one out. 164 again. 53, 44, 29, 153. That is a much larger number than 2 to the 24th.
Okay, yeah. So basically what we're saying is that we like, I guess 2 to the 24th isn't that big.
We're collecting too many states, basically. Like we can't keep all these cache keys around.
Yeah.
Okay, that's reasonable.
It's reasonable. 2 to the 24th is a big number, but it's not actually that big. Because 2 to the 32
it's not that...
is what, 4 billion?
Yeah,
what is
and
uint
so
max? Uint 32 max.
Here's 2 to the 24. Here's the number multiplied. All these numbers multiplied.
Oh yeah,
together.
2 to the 24th is tiny. 16 million. That's very small.
Relatively tiny, yeah. Versus whatever this number is.
Yeah, this number might actually be intractably large. Actually, I don't think our regular computers can handle numbers this, like objects that are this size. Because what is that? This is 1,000, 100,000s. This is 700 million. This is 38 billion. This is 920 trillion. 6 quadrillion. That's pretty big. Yeah, like I think even if you try to just like add 6 quadrillion times, or 7 quadrillion in this case, you would.
And like we probably don't. That's probably that's if there's a button that presses each one of these states once, and you have to get there.
Yeah.
But it's still, I feel like yeah, we're still doing very large stuff. So, okay, we need to think about how to reduce our storage on this. We're being space inefficient.
So it's not the storage thing, because I don't think you can. I don't think that's a reducible problem, right? I think that our whole algorithm depends on being able to restore a separate key for every single possibility. Like every state that we encounter, we need to keep track of, right?
So. You know what? We no longer have a infinite problem on this one. There's no toggling. We can't actually spin out.
But we do want to not go down a recursive tree if we've seen it before.
Yeah. That's true.
Which requires us to store the exact state that we've gotten to, right? So it's the same. I do think that this problem is irreducible based on our current algorithm. So what makes this horrible and what makes this like a mathematical thing is that like I think we actually have to reason about how these numbers are being added into the joltage state, right? Like
what do you mean?
we have to look at the numbers and say, like, for example, can we analyze each one of these things and say, oh, I'm just gonna press one of these things 10 10 times in order to get all of these numbers up, and then press some combination of the other numbers to kind of fine tune it into what it needs to be.
To tune it,
yeah. And that maybe requires us trying to understand, for example, something about modular arithmetic here, which one of these things are like perfect divisors of these numbers. We can also try bundling the buttons together, like adding them together and turning them to composite buttons.
And I wonder if there's any like way to find subsequences, like can we like set some of the buttons and not the others and like break the problem up. Okay, this sucks.
This actually, there might be a more clever thing than I'm talking about, but if we went down the direction that I'm talking about, it might constitute my least favorite type of admin of code problem, which is just like numeric analysis, right?
Okay, well, I'm satisfied. I'm glad we tried this, and yeah.
Okay, let us noodle on it for 90 more seconds to see if there's anything else
absolutely
obvious. And I wonder if chat has any intuition as well. I'm curious. Chat's been good to us so far. Yeah, but they're quiet.
I was hoping someone would be like, "It's easy.
It's easy.
Just
do this."
No,
yeah,
it's not, and they know it.
Yeah. So just to sort of like, I think the examples are typically easier to think about, right? So let's maybe see if there's a simpler example, right? So like if we looked at this thing, can we be smarter than just like arbitrarily pressing buttons, which is essentially what our algorithm is doing, right? Our algorithm is like arbitrarily pressing buttons and making sure we don't do the same thing again, right? That's essentially all we're doing. So is there a way that we can actually think about the numbers a little bit, right?
Yeah, like what we've got is, I'm trying to think of how we could think about this as like, if we look at this, how many applications of each button do we need to do to like reach? Okay, so here's my thinking. Can we reduce this somehow? Like, is 3, 5, 4, 7 the same as like 0, 2, 1, 3 or something? Can we cut the minimum off a bunch of these and like get to a known state, and like shorten the problem? Like, if we know how to set everything to 1, can we repeat that?
Yeah, or some of these buttons like just simply combinations of the others, right? Does it do they? I somehow think these are all probably irreducible. That would make the problem harder, right?
I don't see any overlap in this example.
Right, like it's basically like one of these buttons a linear combination of any of the other buttons. I think that's what I'm saying, right? Like, and
yeah. Oh, you know what? Actually, that's not true. There's 2, 3, and there's 0, 1, 2, 3, 4, 0, 3, 4, 1, 2 on the third problem. So actually, yeah, that alone does make some of this simpler, doesn't it? Yeah, some of these are reducible.
The problem is that the linear combination thing that I said doesn't let you get rid of the button entirely, because you may need the smaller ones just to like incrementally get you
to fine tune it.
Yeah, exactly. Okay, I think that was 90 seconds of noodling. I think we're good.
Yeah, man.
My conclusion is there is some math. There is some math.
There's a little bit of math. There's a little
bit. We don't want to have to think about.
I think the reason why I don't like these problems is that I think modular arithmetic in particular makes me deeply uncomfortable, because it's just the same math that you were learning when you're in elementary school, but it's so hard. I literally find myself doing this when I do modular arithmetic. Do you know what I mean? Like, you're trying, like, did I wrap around 0? I got to go backwards now, you know? Okay. Well, as this is the tradition of the stream, we're not just about programming, we're also going to talk a little bit about video games. And tonight's topic is Arc Raiders. Should I present, or do you want to present, Dom?
No, go for it. You're good at the screenshot. I feel like you always have a good, just like, you pick something.
Okay, sounds good. All right, so let's then just move over here. And we have notes, but I will... So it was great to have Jim on the stream for the programming, But in particular, he is an Arc Raiders fan, as is Dom. So I want to talk about Arc Raiders. So
multiplayer game of the year, I'll have you know.
Did it just win?
It did, yeah.
Okay. Congratulations, Arc Raiders.
Jeff, did you put any money on your prediction market for
Arc Raiders? I did not have any
for actual game of the year.
No, I don't have any action on anything, but I talked a big
That's
game last stream.
You did indeed.
Or it wasn't last stream. It was a couple streams ago, but yes. I am. I don't want to talk about my stuff first. I put my notes in here first just because I started the doc. I think I might already be mid bounce after playing it for a couple hours, but I still want to play some more. So Dom, where do we start? Where do we start the conversation? You can moderate, Jim. You can also pipe in.
Not Italian enough.
Yeah.
Yeah, I was gonna say let's talk about the aesthetic. The aesthetic's really interesting.
Yeah.
It is 70s junkyard. I think Star Wars is 100% the right comparison. Like the good Star Wars, not the bad Star Wars.
Jim, were you saying Star Wars, or who was saying Star?
You know what? That's funny. I'm not only making that association because you said it, but that probably would not have been my first. I didn't immediately have that gut instinct about it.
And when we say we mean like Star Wars: A New Hope, Star Wars, right?
Yeah, it's got Millennium Falcon aesthetics.
Is Ralph McQuarrie? I think Ralph McQuarrie might be a little bit too smooth and polished for he's not trashy enough, right? Like this is not.
No.
Yeah. We're talking about like Star Wars outtakes with Biggs on Tatooine, kind of like trash aesthetic, right? Like,
I mean, Tatooine, yeah, Tatooine aesthetic is great.
Yeah,
that aesthetic always gave me this weird,
guys,
trashy
right?
art deco kind of thing that wasn't quite the same as. Like Arc Raiders has more of a junk object thing, and it's not just like the shapes are like bold and linear in a certain way that Ralph McQuarrie is. Yeah, I think Art Deco actually when I think of him.
Right.
Yeah, Mos Eisley. Yeah, it's weird. It's weird that Italy is so sandy, but like, yeah, a bit of Concord, a bit of that like. Guardians of the Galaxy, like we got mixtapes and bright colors aesthetic.
Yeah. Is there a little bit of Jodorowsky's Dune in this as well? I
would also say a little too clean.
A little
but
too clean,
I love that art.
Okay.
Jodorowsky's Dune is just
this is a little too clean.
A+. This was Mobius and Geiger together.
Oh my god, yeah. That's
yeah. It was the dream. This movie, if made, would have been incredible. The documentary was shockingly interesting.
I think you can buy the book. Can you not?
Oh, I think that's an AI generated image and not actually part of the movie at all. Which
can you buy the storyboard book? It's probably like $1,000, right? Jim, do you know what we're talking about? Alejandro Jodorowsky. He's a filmmaker. I think most famous for his 70s or maybe late 60s stuff. But he was going to do Dune before David Lynch's version. And there's this whole documentary.
I vaguely know. Know.
There's like a whole documentary about him doing this, and I think who's the guy? Nicholas Winding Refn. I never knew how to pronounce that guy's name, but he directed Drive, the Gosling. I'm a good mafia driver guy, but he basically like he's like the host of this documentary, and he's talking about like this. All of like the pre-production material that it made for that Jodorowsky, or is it Jodorowsky? Soft J? Like, I don't know.
I assume it's Jodorowsky, just given where he's from. Yeah,
Soft J. But he, he made these incredible storyboards, and like H.R. Geiger was involved. I think H.R. Geiger's in the documentary. He's just like a weird dude, right? He's really funny. Anyways,
oh yeah, he's a strange little man.
He's a strange, like shrewish, kind of creepy dude. Yeah. But let us talk about Arc Raiders and the aesthetic.
I was going to say, there's a little Geiger in this too. Like the robots have a very sort of like fuck you up aesthetic that they're sort of cosmic horror-y.
Are they called arcs?
Giant spiders.
They're
just called arcs, yeah.
These guys. Do you feel Geiger right now? This kind of just feels...
No,
I guess I was thinking the Leaper, but yeah.
What's the Leaper?
It's. I don't think it's quite organic enough.
Okay.
You're right. Yeah.
There's no hands. where hands
No, yeah, there's no
hands
hands or
should not
veins.
hands should not be. Right.
That is the Geiger
That is
aesthetic.
the Geiger
Yeah.
aesthetic, yeah.
Um,
But yeah, so we've got
but yeah,
Arc Raiders aesthetic here.
aesthetically, I don't know why the fuck this is set in Italy. It they should have comical accents, and like we should be waving the Italian flag around while you play this game. Like, just wildly missed opportunities. This should be so Italian.
Yeah. So, okay, first of all, for context, Arc Raiders is a game made by Embark Studios, which I believe is Swedish, right? European.
Yeah,
Yeah.
yeah, and they also made the finals.
Yep.
And it's the former team that made Star Wars Battlefront, the most recent version, and Battlefield. It's like X Dice EA.
X Dice,
people.
yeah.
X Dice.
Yeah.
Yes, I would love to talk about the technical side of that, but I will save that for later because I want to talk about Frostbite Engine. I want to talk about Rust a little bit, but like we'll talk about that later if there's time. Yeah.
Wait, is it on Frostbite too?
It is not on Frostbite, but okay. Let me give you the 2-second spiel about all that stuff, and we can never talk about it again. So
Yeah,
I
do it.
think that Embark's CEO is a guy named Patrick Yoderland or Yogerland or something like that. Sunderland. Something
Sounds right.
Something very Nordic sounding, right? His ancestors were Vikings, pillaging the European coastlines. At any rate, he was very famous for he did all the Battlefields. They made Frostbite Engine, really really quick killer technology. Jim, you were like a Battlefield 2 guy, right? Am I right?
Yeah, which is to me, it's like not the same game as any other one that was after it.
Yeah. I don't recall you being as into a game quite that way as you were with Battlefield. Maybe the racing games as well, but like that's like a pretty major achievement. One of the games that I remember being the early ones where you were like in this like massive team and like people had different jobs, right? You could just be like a pilot. You could just be a medic, you know. But anyways, this guy who's the head of Dice EA becomes like some VP in EA broadly, and he's very famous for like essentially saying we should use Frostbite for all of our subsidiary studios, right? I think Jason Schreier talks about this a lot, where basically that was like a catastrophic technical decision for a lot of the EA studios, and I think most prominently BioWare, right?
Yes, this was. I remember this impacted like a Mass Effect and a couple Dragon Ages, and they complained about it so much. And like Frostbite was the Battlefield engine, and now it's used in NHL games. Every Madden game,
Right,
is Frostbite. So like, an engine's an engine, but also seems like a mess.
yeah, and it's like kind of optimized for the Battlefield experience, but then when you try to plop it into like a Dragon Age where you need maybe a lot more surface area and you need to be able to track different types of objects and larger objects, that and for games that are not multiplayer too, right? Like all of the things that you were optimizing before aren't applying anymore.
That's right. And I was going to say, famously, Anthem is really the one that I think was they forced BioWare to use an engine and make a different type of game.
Okay, yeah.
And that all went south
so fast. Jim, did you play Anthem?
Did anyone play Anthem?
It's funny. I remember when the first trailer came out, and I was with a buddy at work, and we were like looking at it. We were like, that's too good to be true. Turns out it was too good to be true.
It's way too good to be true, yeah.
I think I played it for like a half second, and it was just so... I was like flying around in some inner cave jungle shooting things, and it was just so thin that I just immediately gave up after 10 minutes.
Yeah, it was like Iron Man the game, but you couldn't do anything.
Yeah. You know what? I think we all played this. Did we not? Did we not play?
You had to pay $60. I didn't want to play this.
Did I pay $60 for this? If I go back,
I definitely did pay. Was that on the day where you could do like a demo?
There might have been like a demo,
maybe,
or like a beta or something.
Back in the days where they had that, yeah.
That sounds likely.
I think it was just that they basically they had like 6 months to actually make the content of this game and the gameplay of this game because they just had to like get all the basic like can I move a dude around and render the canyons, right? And I remember playing it, and it's like worse than like an NES space shooter, right? It's just like you're shooting these like purple discs out of your guy, and it's like spammy, and there's no feel to it whatsoever. Man, my heart.
Yeah, there's no game there.
Yeah, my
Yeah,
heart
it
goes
was
out to
tragic.
you.
Remember the whole like? Do you guys remember like the cinematic beginning? I think you're kind of like walking around, and then you kind of like find your power armor to like get into, and there's like characters. I think you just like some kind of dialogue or story.
Yeah,
So they're kind of like setting you up for all that, and then it's just like, well, what am I doing?
yeah.
Why am I flying around
I
this
mean,
cave?
the idea of this looks great. Boy, I would play this game if it was actually a game.
I mean, I wish BioWare still made BioWare games. They were really good at it for a
Yeah.
minute.
All right, well, enough about Anthem. That was my technology rant. But so that guy is like kind of responsible for like almost, or I don't know, like internal company things are complicated, right? Who knows what happened? But he has now successfully made a different company that is like doing really cool, interesting technological things. And so,
And it's funny. Yeah, if that was his sort of baby, he's made 2 really successful Unreal Engine 5 games since then. So good for him.
Is this Unreal Engine 5?
It is. Yeah, this is UE5.
Okay, because Embark Studios very famously has a bunch of like, they have like 400 repositories on their GitHub, which
Yeah.
seems kind of crazy to me, given that the game studio can't be that big. Does that mean like
well-
every engineer is like making their own GitHub repositories? Like,
I don't know, but I do want to talk about the tech for this thing because the tech is cool.
okay, maybe. Sorry, let's talk about the game. I'm sorry, I took us down a
Yeah,
rabbit
yeah.
hole. Let's talk about the
That's
game,
okay,
and then we
that's
can
okay.
keep moving forward. Anything else
Yeah,
on aesthetics?
I think this has just some of the best sound design I've ever experienced in a video game.
Yeah.
Oh yeah,
Just
that was like the first thing that I wrote down.
Yeah.
yeah, it's shockingly good. I don't know, like it's their level design is like canyony and mountainy, and there's like building and stuff, and like when you shoot a gun, you hear it echo off these buildings, and like
Yeah.
I try to only play with headphones because you get a really good spatial sense of like, is there a guy to my left or an arc or something? It's just.
Did
it's
you
like,
play
yeah.
Tarkov at all?
Nope. Never. I never Tarkoved. That game did not look fun.
I played it for like a hot minute, but it was just too difficult and hardcore. But that was like I think the first game where you really understood what good sound design. I don't. Okay, what was really good or not is one thing, but the fact of how important sound actually was for you to actually understand what was going on and like how the levels were so different of people walking around. The other thing I will say about the sound design Arc Raiders is those sound effects, those little music jingles that happen, like when you like are ready to go. They're so loud. I don't understand why they're mixed so badly.
They're really loud. Or like it's the jingle that plays when you find like a purple or a really good item too. It's just like the game shouts at you about it.
Right.
Mm-hmm. Those are pretty sick though. The actual jingles are cool.
They feel that. I mean, I'm satisfied, but like I've also been like scared of them a couple times. Like, oh, what happened?
Yeah.
But yeah, so like,
yeah. Go ahead.
oh yeah, go ahead.
Sorry, I was going to change the subject back to the visuals really quickly, and just because I had this idea that when I saw Arc Raiders, it kind of looks like another big multiplayer shooter game that came out recently called Concord. Would you agree with that?
Art-wise,
I think Concord. I think they had sort of like similar setting. To me, Concord always looked so squishy and lo-fi by comparison.
Okay.
I think Concord has just like kind of shit graphics.
So
Concord looked to me like it was just like you went to the central casting catalog of 3D assets and then just like dumped them in there.
It does definitely have that. Sir Nalton saying Conquer was more like Overwatch Marvel Worlds. Gameplay wise, yes, but I would claim that this character here, I guess his name is Da, looks like an Arc Raiders character. Yeah,
such a stupid name. How did they fuck it up so badly?
But this looks like Arc Raiders to me, and yet I think we would argue that Arc Raiders is more successful from an art direction design than
it is. Yeah.
Concord.
It's a similar sort of like cobbled together like dirty future aesthetic, but like if you pop into the game, find like a gameplay screenshot or something. It's like rainbow puke everywhere.
Okay, yeah, it might just be.
There you go on the top left. I'm looking at the stream behind.
Okay, yeah, this one here. Yeah, okay. Yeah, I mean this kind of looks like Destiny or whatever, right?
Yeah, this is like Destiny, Halo. a bad version of both of those.
Or
I think
or
the
Overwatch, as Sir Narleton was pointing out. I think that's what this reminds me of. Yeah.
this is really interesting because I could see what you're saying about some of the aesthetic of the object, but the color design
Yeah.
and then the lighting
Yeah.
is so good in Arc Raiders that I think what it presents is just completely different. And I think Arc Raiders is a lot more pastel and less neon,
Yeah.
which I think also makes like a huge difference, which like I think contrasts really well with the Arc when they're like very like electric, which is like not the same palette.
Yeah, and while this has like this looks very gamey, which is a terrible way to describe this, but like,
Right.
I think it's interesting that in Arc Raiders it's like the same map will come back with like nighttime weather effects, electrical storms. Like I feel like the aesthetic is confident in this way where they're like, cool, like we're gonna change it up versus Concord has this sort of like we baked the whole level in here,
Right.
and everything is just the way it is. I think this is more confident, and I think Concord was so. I don't know how that game got made.
So how I heard I like read about the failure of Concord.
Yeah.
Mhm.
But I never really like actually like scrutinized why it did so poorly. Was it actually just like a shit game?
I think it like wasn't a good game.
Or
Well, it's interesting because like if you like Arc Raiders was sort of like completely retooled, like it was a PvE game, and they play tested it a bunch, decided it wasn't fun enough, and like took it back for a year. And I feel like Concord was like, "Hey, we're coming out," and then they came out, and no one cared. And also, this guy looks like shit.
Yeah. This. So here's the thing: is like I would like to think that had the gameplay actually been good, then I think, like, well, I don't know what I think, but like, I would like to think that had the gameplay actually been good, then people would not be paying attention to the aesthetics that much, or it would just be kind of like a point to laugh at and then to go on and just like spend 80 hours and play the game. But I think the game was like a notch below mid. I think it was like like vaguely bad, right? Like it was like it was made by 200 people, so it's gonna have a certain bar that it's jumping over. But I think it was, I guess, vaguely bad. And then honestly, this is some of the worst character design that I've seen in a game.
Like
Derivative.
People were going on about like woke shit, but
that's exactly what I was saying.
Yeah, it's just bad. Like it's just not interesting in any way. Like I've seen all of these characters.
Oh, this dude here. Once this stream catches up, this dude here who's just like,
holy shit, he's just a guy.
But I will say this guy looks like an Arc Raiders guy, right? This dude looks like an Arc Raiders dude. You can buy this costume in Arc Raiders, and it's probably like 1,000 Eurobucks or whatever.
Absolutely, but they're not. So Arc Raiders is not selling itself as look how cool and unique you're not picking your character based on appearance. For the like, it's sort of like it's paper doll dress up versus this is like this like Overwatchy aesthetic of like, oh, this is the big robot gun character, and this is the giant guy with a red face character. So it's like the aesthetic has to do so much storytelling work for this that guy is just pathetic.
Right.
That's funny. I don't think he looks. I mean, I could see where you say that, but there's something that's almost like Arc Raiders is kind of weird. Like it's almost like non sequitur when you look at some of that. But yeah, it somehow makes sense. Whereas that guy just kind of like McThree character with gun and armor.
Right.
Yeah.
I think what feels coherent about Arc Raiders is like this notion that like people are putting on the clothes they want to put on. Like they're like, oh yeah, like dress up, like dress loud and shoot loud or something, or dress loud and walk quiet is like a thing they say a couple times. Where it's like it's like it seems like it's a thing that they're like, oh yeah, some people like wearing like spacesuits. Versus Conqueror is just like he has football pads on because that's his character. His character is football pads.
Yeah. Arc Raiders is a little more steampunk, but with a more futuristic aesthetic, and not like the. I think the steampunk thing is definitely a thing that they're, especially like with the way the weapons look.
Mhm. Yeah, I mean the guns cobbled together. I love it.
Yeah.
Mhm.
Or
Some
if
super interesting aesthetics. Yeah, like you throw things that are just like clearly taped together.
yeah. So I guess my hot take is that like I don't think that Arc Raiders art design is like order of magnitudes better than Concord's. Yet I think it does
No.
kind of prove the point that like a good game trumps everything.
Mhm.
And then it also is worth saying that like Arc Raiders from like a rendering perspective looks fucking amazing. I've been playing Ghost of
Yeah.
Yotei, which I think Dom, you and I had been talking about how it's like it's not
Mhm.
doesn't I mean I guess it's a PS5 game, but it like does not feel as good looking as Ghost of Tsushima did, on the PS4. And then I like played Arc Raiders, and I was like, whoa! I feel like I literally upgraded like a console generation or two when I was like playing it. Like,
It looks so good, and I have to assume they're using like it's like all weird nanite shit,
yeah, it's
right? Like
all
they're
the
probably getting
yeah,
away. It's like photogrammetry of like yeah, like surfaces and mountains and deserts
yeah.
and buildings, and like they're just using UE5 as to the max, and like it looks really good.
And I would say I actually think it looks well. I don't know. I haven't played Clair Obscur in a little while, but Clair Obscur was the other like Unreal Engine 5 game that we've all played recently. But that was like I think very famously they were punching above their weight class technically. But
They
I
were.
think it's like a notch. It's like in a different tier than even
Cl-
Clair Obscur.
Clair
I'd say.
Obscur's like texture and details weren't this high. Like they were using much lower res models, I think.
Yeah, and I think Clair Obscur
Like more
also
more
has
stylized, more
more
stylized.
stylized, and
Yeah.
also I think they had the kind of like animation wise, they kind of had like the floaty. It's clearly a capsule like that's just like running along the
Yeah.
ground, you know.
Yeah. Yeah.
Anyways, let's go off of
And there's
aesthetics.
something,
Let's talk about the gameplay a little bit.
What were you gonna say,
Don, where were
Jim?
you in general on extraction shooters?
I'm having like a multiplayer renaissance for myself. And this is like kind of the first real extraction shooter I've played. Like that's not true. I guess Helldivers. Helldivers I also enjoyed, but like found really stressful in a way that I do not find this experience stressful. Uh,
Oh, it's so funny. I'm like totally opposite. Like I am not a. I guess Helldivers has a full PVE component,
mhm.
and there's almost like a Street Fighter aspect to it, where like when you start getting your loadout and everything going, there's actually a certain like muscle memory to that.
Mhm.
Whereas like I don't think normally I would be a person like I actually still probably play more Helldivers than Arc Raiders. But the fact that I do play Arc Raiders still
Mhm.
is more of like how good that game is. I think naturally it's just like I just
Yeah.
have like way too much stress of just like, okay, am I gonna make it out of here?
They
And
they
like
just
I don't want to get shot
they
by somebody. And like normally that would turn
yeah.
me off, but I still go back to it.
I feel like Helldivers it is extraction shootery in the literal sense that you go to a place at the end of the level and call a ship in and have to survive to get out. The
Mhm.
thing though is it doesn't have the kind of like clawing your way to survival feel
Well, you're
that
not gonna lose anything.
you're not going to lose anything. And then no, but you also
Right.
have just cool shit to begin with, right? And I think that was
Yeah.
actually one of the reasons why I didn't enjoy Arc Raiders at first is that I basically have like a pea shooter, like a BB gun, literally. And like it doesn't feel good to shoot that gun.
Mhm.
And I'm just not very good at like thumbstick aiming, and there's zero auto aim. I guess I mentioned in the notes. I think the kids are all right in the 2025. They're all right at using thumbsticks to aim, but like I'm trash at it, right? And so I'm like trying to hit these. Like the first enemies you fight in that game are those like floating, flying little pod things that are really, really small targets. And you miss them, and then you run out of ammo immediately. You know what I mean?
Yep. Yep.
And
That's just time though, you know?
no, but like Helldivers, you can get in and you can just like kill shit immediately, and the guns feel good. And
Yeah.
I'm not trying to like rag on like Arc Raiders right now. I'm
Mm.
just trying to say that the experience of Arc Raiders it feels like it's about the kind of like poverty of it, right? Like it's like
Mhm. Mhm.
poverty aesthetic gameplay. You know?
The gunplay in Arc Raiders to me, at first I thought it would be a little bit wonky because it's not like they have like your super cool reticle where you really feel like you're some soldier shooting some gun. But because of the actual sound design and the fact that it's actually hard to take down things and you get a really sense of accomplishment. Like Jeff, when we were playing with the Jason the other day, and we were just like doing some basic stuff, just like taking down some of those hornets.
Yeah.
And like it felt just so good to survive that moment when everybody was like new doing that.
Right.
And so the gunplay actually feels, I think, much better than it actually would be.
Yeah.
Because of both the actual game design and like the enemy's challenge and the sound.
Maybe it's just because I tried to take two of those things on at the same time, solo, because I was trying to get my fucking dog collar.
Oh, that dog collar, man! Jesus Christ!
Yeah.
Oh, and now I just trip over dog collars. They're fucking everywhere.
I stuck it in my safe pocket, so I think I got it, even though I died almost immediately afterwards.
Yep.
But
that's what it's for.
But the sort of like constant sense of scarcity inside of Arc Raiders, I felt that from the get-go when I played alone, and I was just like, my stamina was scarce, my ammo was scarce. I mean, actually, you have plenty of ammo, but you can't use it. It's just like because you have to reload all the time.
Reload is so slow.
And so, like, I fought a hornet or whatever those things are called, and he basically depleted my entire band-aid stash, and I was just like trying to run away from him, but I was just slow. All the tactics that I normally use for these games, I couldn't use.
So we can talk about the Arc. I think the Arc are some of the toughest AIs I've ever fought in a game. Like,
interesting, yeah.
They are fairly smart and flank you, and they've flown inside buildings. Like, they know where I am in cover.
Yeah.
They're really challenging, and it's like, and I think that this is part of their technical solution. Like the Leaper has been machine learned how to walk on 4 legs, and is running like a weird machine learning model to step forward.
Super cool.
I think everything it's incredibly cool. Like this game,
it's the logical conclusion to the Boston Dynamics dog thing. So this is
such a better application of that tech, right? Yeah.
Have you guys been watching the Boston Dynamic dog is kind of like I mean, they still make it. It's still creepy. It's still funny. But I feel like the newest things are those like boxing robots from China. Do you know what I'm talking about? That do Taekwondo and
I
stuff?
saw the boxing robot from China, and I thought the dog was going to kill me. Now I'm fairly sure the boxing robot is going to kill me.
But they're super funny. They're even funnier than the dog, because they like fall over in funny ways. Do you know what I mean?
Oh, I think I was thinking about the ones that like kick the guy over.
Oh, you're saying they have these guys, but they kick over a human.
Yeah. I watched a video of one like kicking a dude, and I was like, no, thank you.
Oh no. See, I was watching a video of the opposite of what you're talking about. But you know, we're only a couple years away from these guys just like totally fucking dominating us, right?
Yeah.
They shouldn't have given the dogs guns. They're going to give these guns.
It's Chappie.
Oh, there's no question.
It's Chappie.
Don, how do you think about the difference? Well, first of all, how do you usually play Arc Raiders? Do you play with people or do you go solo? And then how do you think about the difference between those two? Because I think it's a very, very large difference.
It's a very,
which is a little bit of a shame.
It's a very big difference. Yeah, I also don't like that the solo experience is so much, I think, better than the team's experience, because the team's experience is like always shoot on sight.
It's all shoot on sight. Yeah.
Everyone gets so confident that like they can take the other team because they're not alone. And in solos, people are sneaky and friendly, and you have to have this like social interaction and weird negotiation every time you run into someone, because no one can save your ass. And I think that's just a delightful experience.
It is.
Yeah, even getting killed in solos I find delightful. In teams, it's a lot less fun, and I'm happy when we persevere. But a lot of times, a lot of my team deaths are like teams fighting, and then like an arc comes over and fucks everyone up, or like ends my run when I'm limping away, and I'm just like, oh, fine, you win.
Do you think they could design some middle ground there?
Yeah, I've talked about this with Narleton and others, but like I think they're like, it would be worth signaling like I want to be friendly, or like I think they could take stronger signals about like if you're not shooting other players, like they put you in lobbies where people aren't shooting other players. Like I think they could probably match make some niceness into it if they want. And then like I think they could also like punish people who are shooting randos if they think that's a thing worth punishing. It's hard to say.
A bounty system on the comments, that'd be funny to see.
Yeah. And like, I wonder, like, is it a bounty for the person that killed you, or should they put bounties on like people who just kill random raiders and like they just accumulate bigger and bigger bounties, and then you have an actual target of this person in game of like this person's a a rat, a gear stealer, and that'd be neat. I think it'd be really fun to give me a reason to shoot someone on site who is like a bounty target, because then social interaction done. I want that bounty.
Like I have this feeling that they could either add more arc or make them more or harder and just have a full PvE experience. And I think that it'd probably like mess up the economy, but kind of who cares about that? But I feel like they could do that.
Yeah, well, and it's interesting that that was the original game and they like rejected it. And I think it was a very different game loop as well. And it was like a giant open world with arc in it, and you were traveling around. I think the number of people asking for PvE mode right now would be it is a lot and would be really fun, because like I do like fighting. Like I feel very satisfied fighting the arc. Um, and like if there were more of them, it'd be a very weird, exciting game. And like yeah, the shredder they added is great. I love their new designs. I think they're adding more. Uh, the new robots are fucked up in the worst way. So I assume they have a ton of those in the hopper. But yeah, you asked me the way I play, and like my overall thesis to Jeff for this stream has been like Arc Raiders is a roguelike, as much as it is an extraction shooter.
Yeah.
And like
it's a what?
It's a roguelike, like Hades.
Mm-hmm.
And I say that because the existence of the free loadout means I can treat it like a run-based game where I start a run, go in, get gear, and I upgrade myself with what I find in the run. And that
interesting. Yeah.
And then like so I go in free, I come back with stuff, I use that stuff to like upgrade my current loadout. I go back in, but I'm not really I'm avoiding a different way to play the game, which is like sort of specking for a situation. I don't often say like I'm gonna set up for killing the queen or something.
Wait, so just to clarify on that, so do you use free loadout, and then you just maybe what you do is you sort of like keep the same batch of stuff for a couple of play sessions, but you're not really that concerned with like an overarching long-term inventory that you're maintaining.
Basically, well, like I'm getting, I'm extracting with stuff over those play sessions. So, like I'm getting stuff, I'm looking for like upgrade stuff. I will take the opportunity to upgrade my free gun or replace it if I find a better one.
Yeah.
But like basically it's just like I'm doing like a play session.
Yeah.
3 or 4 of those die, and I'm just like, okay, time for new free loadout, and let's go like get some stuff and start again.
Yeah.
Because the sessions are so fast, like it's in and out in 10 to 15 minutes with like a full backpack of stuff and like new weapons.
Do you think that that's advertised enough? Because I think, I guess this is just extraction shooters in general, and they're totally not my genre, so it's hard for me to kind of like say anything valuable about them. But I can imagine it being like if you've tried to play these games where you like tried to hoard your gear and like you really care about having a particular gun. That seems like a bad way to play, right? Or it seems like it's just stressful in a way that is not entertaining,
Yeah, and like what I've acquired through playing is like blueprints for stuff where now I can craft like the really good grenade. I can craft wolf packs, and I've got an extra wolf pack blueprint at this point, which is great. And like they're pretty cheap to craft. I can like bring 3 of them with me into a match and not feel.
Don't give it to Jeff. Definitely give it to me.
If Jeff's gonna bounce, I'll give it to you. Yeah.
Well, I think I should try. Like, we've got that 2-week break coming up, or however many weeks we get off in the tech industry, and like, maybe it's worth trying to play that. Although I might end up getting sucked into Factorio again, so we'll see what happens.
God, I mean, call me if you do, because that's a good time. But like, I can supply you with wolf packs, which is really fun because like they take down a Rocketeer in like 2 shots and are just delightful. They make everything explode. They feel really great.
Yeah.
And like I found one weapon that's great for killing Arc, and I can take a couple with me and like be more powerful. And like I bring it, sometimes if I'm doing like a challenge that I need to kill Arc for, I'll bring a bunch of Arc shit. But yeah, I don't know. Like my backpack, my stash is full, so like I have to use it or lose it. So like I'll do a free run, come back, take a couple things out of my stash, just do that a couple cycles. But like when I die, I'm just like, cool, like time to start a new character, basically.
Yeah. I
So
think
yeah, like weirdly, it's just Hades to me.
yeah, I mean that makes a ton of sense. Yeah.
That's a good attitude to have. I like your attitude, Don.
So Sir Nalton says I should save my sanity. I'm assuming that he's trying to encourage me not to become an arc raider sicko, right?
Naruto and I ruined this game for him basically. We were playing this together a couple weeks ago, and like just got like ganked by randos 3 games in a row. Lost a ton of shit. We were like going on a mission and just like immediately murdered by strangers.
Yeah.
Which feels bad.
Yeah.
It was very unpleasant, and I felt bad because like I made someone queue into duos. Yeah, the rats, those rats. I think I mean, this game studio has put together such a complex, interesting dynamic of a game loop that I think they probably care very much about tuning it away from behaviors like that.
Sure.
But we will see.
Yeah.
It is up to them to show that. And it's weird. There's like a social dynamic. Like the game's current season is ending in a couple weeks, and people there's a timed character reset coming up, so you can choose to reset your character, and if you reset with a certain amount of money in your inventory, you get like a bigger bonus. And so now people have turned into extreme mercenaries because they want as much money, as much monetary value as possible. So they are just like, if they think you might have something valuable, they really want to kill
Ultra
you.
aggro.
Yeah, because they want to accumulate this 5 million so they can reset their character with more skill points. And like, I think it's super interesting that that's like a social dynamic created by a temporal game loop. That's pretty cool.
Yeah,
It's also very fucking annoying right now.
I see. Yeah, I think Jim, you said some comment in like one of our Discord channels or something like that. Like, I look forward to getting ganked by a 13-year-old who's screaming into voice chat or something like that.
yeah, or just being, I'll just some Eastern European dude is just like cheating. That's apparently like a big thing. Just like, I don't want to play. It's like it's a whole like I don't want to play on the Russian server.
I like the ethnic component to this. Yeah, I like how it's fueling. It's fueling a dissension amongst the various races of the world.
Look, you can't be racist.
That's just more of a reference to just what you see on Reddit all the time.
Yeah. Is Arc Raider secretly a divide and conquer mechanism to keep the working class down?
Oh gosh.
Possibly. I would say by and large, though, like especially on solo, 9 out of 10 times it's like I have a really good fun, good, positive interaction with people.
That's a pretty good hit rate.
Yep.
And then the one time you die, it really like pisses you off because like you have something that you want to bring back.
Yeah, all my good interactions are when I'm not carrying something I care about, and then I get killed by someone when I have something I really want to take back with me every time.
Yeah.
Dom, I might try to
safe pocket.
Yeah, I might try to play the game the way that you play it, which is just like lean into the free loadout and just like build off of that, and just let that be like a little seed for the next couple of sessions until you die, and then not care if you have to start over again. Because like the inventory management, like when I like within like the first 5 or 10 minutes of the game, I'd filled up my backpack, and I was like I was spending an inordinate amount of time trying to decide whether to throw away piece of detritus X or like piece of fucking garbage Z. You know what I mean? And it was just like, why am I making these decisions right now in this game when the gameplay is or when like the gun feel is so bad? Like, what am I doing here? You know, like what? So I think maybe a change in attitude is maybe something different, because I think perhaps what I'm experiencing is like kind of veteran extraction shooter, run and gun. So it's not first person, but it might as well be kind of like all these kind of like tropes of games that I just don't play. And I'm coming in bringing this sort of like Witcher 3, I'm going to hoard every fucking thing I find sort of mentality, because it's all about the accumulation in the games that I play. And maybe I should sort of approach it with less of that attitude.
Yeah, it's interesting. Like the only thing I'm really trying to accumulate are blueprints and like whatever I've got tagged for like quests or upgrades, and like everything else is kind of.
You got to make your chicken better.
Gotta make chicken better. Yeah. Weirdly, fruit is the highest desire item I have right now. I need mushrooms and like apricots. It's weird.
When I play with Jim, we literally spent, I think, 30% of our time punching trees, and I was like, oh, this is this type of game. Nice.
It's weird because it's like it's not a tree punching game, but they still have you punching trees. Yeah.
Okay, well, we're kind of at time. Any sort of last thoughts about Arc Raiders, Dom's game of the year?
I think it's just, I've had so many interesting stories and dynamics come out of this that like, it's that thing that they promised AI games would be, where you can just have, random NPC interactions, but it's just other people that are more fun.
Yeah. Jim? Are you going to keep playing, Jim, is my question for you. I think we lost Jim's audio, so I'm not.
Oh no, where'd your audio go?
Yeah.
Oh no. Right at the critical moment.
It's okay.
Wait. While we're waiting for the audio to come back, Norris does mention when you go in there, bring the recorder. This game has a jazz flute, and the jazz flute is one of the best items in the game. I don't know if you've encountered this yet.
No, that changes my attitude entirely, actually.
That's great. I like spend money to buy extra jazz flutes to take in with me because it's so funny.
Yeah. Well, I will definitely do that. I think the instrument of the stream this year is the saxophone. So if they add that to the game, I'll definitely play. I promise.
I wish it had a saxophone, man.
Yeah. Yeah. Well, Jim is saying in chat, because of the time difference, he doesn't have a regular crew, so it's like still a whole different dynamic. Makes sense.
That's real.
Okay, Doke. Well, we're kind of getting towards. I guess we have a couple more streams left, right? Tomorrow is Friday in the U.S. Our stream then will be at the normal time, 7 p.m. Pacific. We'll be doing, I think, day 11. But we already have like two problems, two puzzles in debt right now. So the backlog is already growing.
I know.
And they're not easy ones. They don't have, like most puzzles, you just have the intuition within a couple seconds, and you're like, well, it's just a matter of iterating and getting rid of the edge cases. But we'll see how it goes. Tomorrow night's chat subject, I believe, is the Stereo Boy retrospective. So I think we need to dust off whatever version of Unity that we had in the past, so we can talk about what it was like to make our first and currently only Steam published game. We've made a lot of games, but Stereo Boy was the one that we worked really, really hard on, and we want to talk about sort of how we feel about it 3 years later, and maybe what lessons we learned going into our next game. And then we will have another stream, for sure now, because we're definitely not going to finish all the problems. Another stream on this Saturday, the 13th at 10 a.m. Pacific.
Yep.
And I don't even know if we'll finish the whole series, but we'll see what happens. All right.
Yeah, we'll make our best effort. I don't want to be defeated by 12 days of programming. We'll see.
Yeah. It got hard quick, I think, is what happened.
I asked for this.
Yeah. Okay, doke. Well, thank you, Jim, for joining us all the way from Taiwan. Chat, Solus Rez, and Gnarlton, thank you for hanging out. And we will see everybody tomorrow. Take care.
All right.